Hey, thanks for coming. And if you're not here to listen to us talk about Radar, you're welcome to leave right now. No need to stay. I don't want you to be disinterested. But I am really excited to be here and talk to you today. Jason and I have been excited to share this journey for quite some time now. We are both at Liberty Mutual. Jason and I are both members of the Secure DevOps team within our hosting services organization. And what that team is it provides the end-to-end platform that our developers need to deploy into the cloud. So starting from providing a clear developer experience, providing insights and enablement capabilities that our developers need, all the way through to our engineering teams and services that provide our cloud infrastructures, our runtimes, as well as the pipelines that our teams use to deploy into the cloud. At Liberty Mutual, we do not allow our developers to deploy into the cloud without going through a pipeline. So just a little context there for as we go through this presentation, you'll start to understand why Radar was so important to what we do every day. Jason and I have been part of the AWS community for well over 6 years now, and a lot has changed. We've been through account and VPC redesigns, at least 3 or 4. We've been through a couple of audits, and we found ourselves buried in application modernization, replatforming, and even some lift and shift. And we're better for it, because now we're able to securely deliver global services to Liberty Mutual. So let me tell you a little bit about what our AWS profile looks like. We run AWS as a product. And as I had mentioned before, we're part of a central team that manages that end-to-end infrastructure of all the cloud providers at Liberty Mutual. Provisioning and management of the entire infrastructure, from accounts to VPCs to security controls, has been automated. And it's consistently delivered across 14 different environments. As you can see from the list here, we manage well over 150 accounts, over 180 VPCs. And within those, from the initial deployments, the updates to services, IAM policy, security controls, again, it's all automated. And that automation enforces parity and enables our developers to focus on the application development and delivering business value. At Liberty, I'm sure the story isn't any different from other enterprises. Not only have we committed to the cloud, but we've committed to the way we're changing development. Brian spoke about this yesterday. We're working through an agile transformation. We're focused on developer empowerment, and our goal is to have 40% of our workload in the cloud by the end of 2019. And we can't empower developers, enforce security, and enforce compliance of policy in this massive footprint without automating everything. So I have a couple of interactive questions for you. I hope everyone wants to participate. How many of you have unencrypted S3 buckets in your environment? Come on. All right, thank you so much. Raise your hand loud and proud. Who has instances that have been running longer than, or been running since 2015? All right, a couple of you. Are you patching in place? How are you managing those vulnerabilities? Does anyone have keys in use older than 90 days? How are we managing those key life cycles and ensuring that we're replacing them as needed? And do you know the risk profile of your entire AWS footprint? At Liberty Mutual, as we look across all 180 VPCs, it's more than each individual risk or vulnerability. We need to understand how we are securing the entire environment and how we are enforcing those controls. Does anyone feel like they're a part of a security team and your only job is to say no? On traditional teams, we were brought through various waterfall stage gates to review and approve designs. We were vetting designs that felt like were made in a vacuum. Those meetings usually lasted an hour, and we were simply forced to move on to the next team. And like buying your first house, you really never knew what was real and what was just a patch job. And even as we start to experiment in the cloud, many organizations had not made the necessary organizational changes to adapt. Security in one area, developers in another, network completely separated from everyone else. And as you know, in moving to the cloud, So much of the successful delivery is counted on all of us working together. And after all, that's why we're all moving to Agile. I am sure some of you all had teams that were early Agile adopters. They tried to move so quickly, yet they struggled as they were forced back into traditional stage gates and processes. Developers were frustrated. We were frustrated as security professionals, and no one was working together to provide clear security controls for the cloud. Has anyone actually had to quarantine or shut down an application in prod? Okay, well, that's terrible. Don't ever have to do that. And to compound the confusion, AWS had stated that they have a shared security model. But what does that really mean? With no clear understanding of where responsibility started and ended, security was forced to secure the environment by saying no, and thus, in the developer's eyes, limiting progress. And we started to see our development teams change the way they operated, and we knew we needed to change too. So security documented everything. We knew we could simply not continue to say no. Documentation became the go-to. Pages of compliance needs, risks, risk scenarios, general cloud security guidelines. We provided references to standards, policies, guardrails, risks on wiki pages, websites, and hard-to-find SharePoint sites. But feedback from developers was nothing was still clear. There was no indication of what was good and what was right. Standards provided great details on expectations and requirements, but no indication was given of what was acceptable. Our Agile teams wanted clear acceptance criteria. Where a developer could find information on where there was no place for developers to find information on the implementation details that would make them successful. How were we giving them the information to ensure that the risks were mitigated? And then even worse, what if we had development teams solving the same problem 3 different ways? As a community of cloud security professionals, we knew we needed to avoid, prevent, and enforce. And as our application teams were focused on application modernization and replatforming, they didn't have time or desire to review compliance documents on a wiki page. And they also didn't have time to have no context into what they were actually trying to prevent. We became blockers in the CI/CD process because what seemed like overnight, empowered developers were leveraging pipelines and were no longer staging ear files on a server at 3 a.m. in the morning. They were deploying changes to code in a day. Infrastructure APIs had provided developer more capabilities, and it was time for security to catch up. Dance like no one is watching, encrypt like everyone is. A turning point in 2017 when Vernon stated this at the 2017 reInvent keynote. You need to protect data in transit and at rest. I believe we haven't taken encryption seriously enough. Encryption is the only tool we have to protect your data. Dance like no one is watching, encrypt like everyone is. So you get encryption, and you get encryption, and you get encryption. And developers were psyched to have clear guidelines finally. Cloud environments were different than on-prem, and we needed to focus on protection. But as developers found those guidelines clear, we still had the same question from a security perspective: was encryption really enough? One of the greatest concerns security teams have in moving to a developer-managed infrastructure is the possibility of a well-intentioned developer implementing misconfigurations that could expose systems or data to enhanced risk. We've empowered our developers to move at the speed of business. The challenge is, how do we quickly, as security professionals, truly prevent risk exposure in lockstep with the development track and not become a roadblock? As I mentioned before, at Liberty, we're focused on developer enablement. Before, the worst thing a developer could do is introduce a bug. Now with CI/CD, developers are empowered to deploy all the way through to production, and they have the power to unintentionally deploy an unencrypted S3 bucket or Even worse, take down a single environment with one click. So how did Liberty Mutual stand up to this challenge? We automated policy in order to allow our teams to scale. As Brian shared yesterday, core to Liberty Mutual's business is that progress happens when people feel secure. So at Liberty, we took the documented security standards and policies and automated the enforcement of them. We then deployed it with the same code we used to deploy our entire AWS infrastructure. So it was consistent across all the different environments. The Liberty Mutual cloud product teams, as well as the Liberty Mutual risk management teams, partnered to enforce the policies with automation. And then rather than having developers look at a reference site, they were able to focus on delivering business value. We've also introduced policy directly into the CI/CD pipelines, so we can prevent mistakes from happening by failing deployments, so things don't even make it into production. And fundamentally, it's about enforcing security policy via code rather than working through laborious manual processes of reviews and stage gates. And by doing this, we're working at the same pace as developers. We're no longer blockers because security policy scales with each deployment. We are enforcing security policy as code. We're preventing, detecting, correcting, remediating, enforcing, and providing visualization for everything we do in the cloud. We call this service Radar, and it has been enabled across all of our 157 accounts in both prod and non-production. Radar is a framework that monitors all resources spun up in the cloud. The service assesses configuration on the state of new resources. It identifies any misconfigurations that deviates from the security standards. And if a misconfiguration is identified, the service will automatically bring the resource into compliance or remove the threat from the environment by stopping or terminating the resource within minutes of deployment. We can find those pesky S3 unencrypted buckets. And for items that are shut down, only developers, once they remediate the issue, can bring it back up if it meets standards. All cloud accounts are built with code at Liberty Mutual, and that code includes the guardrails, standards, and policies for running applications in this environment. As I'd mentioned before, the code is based on Liberty Mutual's public cloud standard and enables developers to deploy infrastructure and application freely, while ensuring only compliant resources remain active. This is a major step forward in our secure public cloud adoption, and it allows us to go beyond detection and ensure compliance through a self-healing infrastructure. That's our journey, that's our business case, and Jason's going to share more about the technical implementation.
So thank you, Jay. As she mentioned, I'm going to walk through some of the technical details of Radar, and then we'll jump in and take a quick look at a demo that we put together for today's presentation. So first, I also have a few questions, perhaps not as revealing as some of Jay's questions, but first, how many developers do we have here in the room? Good, good. For anyone else, and including developers, how many people think they understand or have a general idea of what this code is doing here on the slide? Good. How many people are just disappointed there's no more cute, funny pictures of kids? All right. The point here is that you don't need to be a developer to understand this code. It's a human-readable policy, which is great, but more importantly, it's an actual piece of code that helps ensure that every S3 bucket is always encrypted. So how do we get here? Jay walked us through the journey that most cloud security teams have experienced, or perhaps you are experiencing now. More than likely, you looked at some of the AWS services, or perhaps some of the partners that are speaking here at this conference this week. There's absolutely no shortage of opportunity in this space, so how do you choose a path forward? I don't have that answer because that's going to be different for all of us, but I am here to talk about what we did for our solution, and that's Radar. Radar is an internally developed platform born from our journey towards empowering developers to deliver cloud workloads more quickly, but more importantly, more securely. It was not our first attempt, and we learned a lot along the way. We experimented with vendor products. We built solutions using AWS services like config rules and Lambda functions, but every one of those solutions was lacking for us, so we built Radar. At its core, it's simply a centralized rules engine. We built the application using Spring Boot, which runs on Cloud Foundry on AWS. We used a super lightweight open source library for the rules engine called Easy Rules, which enables annotation-based rules definition. As we saw on the previous slide, Radar configuration is declarative. This means that I don't need to be a developer to understand what the configuration looks like for a given rule. All of the rules or security policy is now defined in a YAML file in a single location, stored in source control, and treated no differently than all of our other application code. Every change to that configuration has an associated ticket, requires a pull request, and a code review before making its way into production. The foundational feature of Radar is based on an event-driven architecture, which I'll go into a lot more detail on the next slide. But at a high level, Radar receives events and processes rules or policy against those events. For example, continuing with the S3 bucket encryption, a CloudWatch event is generated when an S3 bucket is created. That event is received and processed by Radar, which evaluates those S3 rules against the bucket and ensures that that bucket is always encrypted. This is ideal since every single service on AWS always generates an event for Radar to inspect. Another foundational feature of Radar is the ability to report on the current state of all resources across all accounts. This is critical to not only understanding the overall risk profile based on our current policies, but also helps us to understand what the impact of pushing a new policy might be. But, as we've mentioned already, monitoring and reporting is not enough. So we took Radar further, and we enabled what we call active reporting. This allows us to remediate resources as part of the reporting process. So for non-impactful configuration, like S3 bucket encryption, this is always enabled. This feature gives us even more confidence that we're always in compliance, and even if we do happen to miss an event, which is very unlikely, we can still be confident that we will always catch the reporting or catch that resource during the next reporting run. So as I mentioned on the previous slide, Radar is an event-driven architecture. We use CloudFormation to manage the dependencies across every AWS account and region, including CloudWatch rules and IAM roles. More specifically, we're using CloudFormation stack sets, which was one of several key advancements that allowed us to greatly simplify this architecture from some of our previous iterations. We have a single pipeline responsible for managing all of these dependencies across more than 150 accounts in 14 different regions. Another important advancement was the release of the CloudWatch event bus, which allows us to share every event from all of these accounts across every region into a single centralized account where Radar lives. We're using SNS and SQS for the plumbing of the events, which allows us to horizontally scale the application to meet processing demand. Radar is running on Cloud Foundry on AWS, and on average, we're processing more than 100,000 events each day. Once those events are processed, the rules or the results of those rules are published and immediately available to several internal development platforms that are accessible by development teams, so that if Radar does take action against their resources, they're made aware. And lastly, we're also using DynamoDB to store every event processed, along with all of the metadata and any remediation details, which enables us to easily view the history of every resource against each policy, and more importantly, continuously monitor the overall state of all of our AWS environments. All of this, again, in near real time. We're also using DynamoDB for storing the results of each report, so we always have a comprehensive history of every resource along with all of the applicable policies. So how do we manage these policies? As code, yes, but there's a lot more to developing these policies than simply the code itself. We're constantly evaluating new services while partnering closely with our risk management group to ensure continuous compliance with any existing services and new capabilities that are added therein. New services are not available until a thorough security evaluation is done and any gaps in compliance are covered, often with adding new rules to Radar. For AWS specifically, we've talked a lot about S3 encryption, but we're actually enforcing over 100 or nearly 100 rules across more than 20 different services and a lot more to come. We've even taken the pattern beyond targeting specific cloud services, and we've expanded the capabilities to overarching capabilities such as secrets management. So how do developers know about these policies? Do we simply document them? Yes, but we also know that developers aren't the biggest fans of being linked to documentation on some remote site. Context is key. As soon as I check in my code, say a new CloudFormation template that includes an S3 bucket, that code is evaluated against these policies. Is the bucket encryption configuration enabled? Great, build a success. Missing that encryption configuration, we fail the build, and most importantly, we give the exact reason why with a link to detailed documentation helping the developer remediate that configuration. So, as I said, we'll jump right into a quick demo here of a couple different capabilities within Radar. The example here is a simple CloudFormation template. We have an S3 resource defined. You might notice there's very little configuration there, definitely not encrypted. And we also have an RDS database defined in this template. We'll also have a few more resources here just for the purposes of supporting that RDS database as part of this demo. So we'll jump out to the AWS console in our first example, and we'll walk through actually creating the stack, and we'll see what happens. So we'll upload the template that we were just looking at with just those two resources. We'll give the stack a name. We'll apply some tags. And finally, we'll go ahead and create the stack. And we definitely did fast forward some things here because some of these resources, especially the RDS database, takes quite a bit of time to create. But as you can see here, we've already created our S3 bucket. So we'll jump out into the S3 console and we'll take a look at what that configuration looks like based on the template that we just deployed. So eventually, we'll load the configuration of that bucket here. We'll take a look at the properties. And we'll notice a few things. One, server access logging is enabled. That's not something we define in our template. Another thing you notice here is that default encryption is enabled, not something that we had in our template either. Both of these things were picked up by Radar, and immediately, before we were able to even to refresh the console, we were able to see that both of those configurations were enabled. So what about our RDS database? Again, lots of fast forwarding here. That does take time to create, but eventually we'll get to see a result. So we'll check the RDS console and see if that's been created. And it looks like we're still in a creating state, so more waiting. Eventually, we'll see a stack result. All right, finally, rollback failed. So, doesn't sound like the right error, but what actually happened is because that RDS database was missing the encryption configuration, Radar went ahead and destroyed that database before it was even before it finished creating. So just to confirm, jump out to the RDS console again and refresh, and that database is gone. So how would I know that as a developer if I was in the real world scenario and had a pipeline associated with this? This is a view of our internal development platform, and here you can see a number of remediation events in the context of that application that I just deployed. So again, not real world. At Liberty, we don't deploy anything to the cloud without a pipeline. So let's go ahead and check that code into source control. We'll go ahead and make a commit and a push, and behind the scenes, we'll also be doing a quick pull request, and we'll merge that code with master, which will trigger a build on our CI/CD platform. All right, so we'll jump over to the CI/CD platform here. Today happens to be Bamboo. Eventually, we'll see a build get triggered, and we'll take a look at those results. You should expect a pretty quick failure based on what we've been telling you. And it has. So we'll take a look at the logs and see what information I'm getting back here. All right. So there's a number of validation errors here. So as soon as I checked in that template with the lack of S3 encryption, missing the S3 bucket logging, as well as the encryption configuration missing on that RDS instance, all of that is logged here. And then lastly, there is a detailed link to documentation on how they can correct those configurations on their resources. All right, so what's next for Radar? More rules. We're constantly evaluating our security policies against cloud services, and we're building new rules where necessary. We've even begun to build custom rules that don't necessarily align to a particular service. For example, how we manage secrets in our pipelines. We're going to continue to look for these opportunities to leverage Radar to increase our security posture in the cloud, but ultimately, our goal is to take policy as code beyond security. Which brings me to operational excellence. The foundation that we've built with Radar has given light to new ideas and creative new solutions for enforcing any policy, not just cloud security. We're discussing how we can use Radar to integrate even more closely with our development pipelines and give actionable, contextual feedback around architectural best practices. Is your application cloud ready? Radar can help you with that. Is your application multi-AZ? Are you using the latest available instance types? What about cost optimization? Do you have a scheduler configured for your non-prod resources so that they're not wasting money during off hours? Are you targeting the most cost-effective platform? These are all the types of questions that will help us deliver more secure, more stable, and more efficient applications. Our ultimate goal is to effectively implement these types of policies into Radar, all tightly integrated with that development pipeline. And lastly, alternatives. Radar has enabled us to move to the cloud with confidence. We've invested a lot of time into Radar, and there's a lot more to come, but we're also always considering those alternatives. Radar itself was born from considering those alternatives when we had a different solution. So are there other solutions from cloud-native services that we can achieve the same level of confidence through configuration? We think so, and that's why we're looking forward to the evolution of services like AWS organizations, which allow us to define service control policies. We're hopeful that these policies will be capable of preventing the possibility of the misconfigurations that Radar is enforcing today. Other services like AWS's Control Tower, which is currently in preview, I think is now GA, but that also looks very promising, and we're looking forward to hearing more about the future capabilities of each of these services. In the end, our goal is the same. All policy is enforced at the earliest moment of risk. Thank you for listening to our story, and we're available to take questions now, or we're happy to meet with anyone after the session.
It's on mine, right? Go ahead. The question was, we noticed it's not on our GitHub, and that is correct. It's not currently available to public. I'm sorry? The question was not even to buy as a tool. That is being discussed internally today.
For the actual Bamboo integration you demoed, I mean, how are you enforcing the devs to have that? Is that like part of some template build queue that you have for them? Are you having each team go in and integrate it?
Yeah, sure. So real quick, the question was, how are we integrating it into Bamboo? And
Yeah.
Jason's going to answer that.
Yeah, so we definitely have standardized pipelines. So within those pipelines, one of those default configurations or tasks defines the validation service, which ultimately defines those same policies that Radar is enforcing in the active environments. Yep.
Go ahead.
So how are you evaluating the configuration in the build pipeline? Are you building the infrastructure, then evaluating it, or are you actually evaluating the observation within the pipeline?
We actually evaluate the templates themselves.
And are you using something like CFNNAG, or did you write your own engine to do that evaluation?
That's all an internally built engine that we built. So, sorry, I didn't repeat the question. But
Yeah, the question was, are we using CFNNAG? And the response is, we're using our internal
Yep.
engine.
I think
Go
I
ahead.
see a hand back here.
I imagine the development of radar was quite extensive. What are the resource requirements for your team to maintain that product?
Yep. So real quick, the question was, the build of Radar was extensive. What's the maintenance look like? Is that fair? Okay.
Yeah, how much overhead do we have? Is that what you're asking, really? Yeah, so we are a central team. We manage all the different cloud providers. So we have a ton of expectations beyond, obviously, just enforcing or operating a tool like Radar. So really, it's shared responsibility across all of those teams, but the overhead is really just in maintaining policy with existing services. Say AWS releases a new capability, ensuring that we're up to compliance with that service, and then of course evaluating new services and building new rules where applicable. So in terms of kind of steady state, it's really just adding new rules is where most of that, I guess, overhead, if you will, comes in.
Go ahead.
A couple over here.
When a new account is created internally, how are you forcing the CloudWatch events to be created? Is that part of organizations?
So the question was, when a new account is created, how are we enforcing those policies and rules?
Yeah, so again, being that our central team owns all of the creation of those accounts, part of the architectural diagram that we had on there mentioned the deployment of stack sets. So every time a new account is created, that stack set is updated to deploy all of those CloudWatch rules to those accounts.
Over here, go ahead.
Question, it looks like you're using config rules. The question is, are you using just config rules, or what else are you using to document the policies? And in addition, are there different controls by like production, non-production environment, or all environments?
Sure. So the question was, is there consistency across all environments, and are we using only config rules to manage the policies?
So we're not using config rules. We've built an internal rules engine to kind of document those policies, and a lot of that is in that YAML documentation, similar to the first slide we had. And then the second part of the question was,
Are they consistent across non-prod and prod?
yes, for the most part. Of course, there are always exceptions with anything, but as much as we can, those rules are consistent across all accounts.
Go ahead. How do we handle exceptions?
So those exceptions are in that code. So that YAML document that we looked at, the exceptions would be in there. There's a syntax that we allow that allows you to either enforce exceptions at the rule level, say based on a given tag, something like that. But we also do allow exceptions at higher levels for a given account or an OU or an organization unit.
Do you have separate dev, prod versions of Radar? That, not one doing the whole thing, but three different.
Yeah. So the question was, do we have separate environments for Radar? And yes, we have. We treat it just like any other application. Yep.
Go ahead.
Because you guys just have the teams define templates.
So the question was, as application teams to create their templates, how do they manage security groups?
So they are self-defined in those CloudFormation templates. Again, there are rules that validate the configuration of those templates as part of those pipelines, just like with the S3 configurations that we saw.
Go ahead.
Do you only use event-based detection, or do you also use like timing?
The question was, do we use event-based detection, or do we also use timing-based? So there are two kind of core features. One is the event-based approach, which obviously gives us that real-time compliance. Then we also have the reporting capabilities, which are run daily, but we also have the capability to run them at any time if we want to get a quick snapshot of what our footprint looks like across the board.
Go ahead.
Are you using, for the different modules and things and enforcement, are you using Lambdas or another service to run those? Containers, EC2?
Yeah, so it's a Spring Boot app, so it's all self-contained in a single application running on Cloud Foundry. Yep, single code base. Right.
Go ahead in the back.
I'm bad at repeating the question. Sorry, guys.
How do you go about reasoning about, obviously radar itself has a lot of power. How do you go about reasoning about radar security itself?
Can you say that again?
How do you go about reasoning about the security of radar itself? I imagine it has quite a bit of power.
Yeah. So the question is, how do we go about reasoning radar itself? And if I can restate that, are you asking how do we prioritize policy implementation and enforce it from that perspective?
No, what I mean is, how do you, from a security point of view, analyze radar and understand how it affects risk?
How it affects what?
How it affects your risk footprint?
Okay. So radar itself is treated just like any other application, so it needs to obviously adhere to these same rules. But I guess a key point that wasn't made that could have been mentioned is around testing. Testing is critical to this application. And at any given point, if a code change is made, well, I believe at this point we have over 5,000 tests that are run, both unit tests and integration tests, to validate that what that code is defined or what that configuration looks like for a given rule is exactly what's happening. I see a hand in the back.
How do you guys, when you do make a change to a resource, do you tag it that you guys made that change, that your radar made that change? And if you don't, are you recording that change anywhere in case you have to actually comment on that?
Yeah, so the question was, when radar does make a change, are we recording it and are we keeping it? So if we ever had to go back and understand what happened.
Yeah, so we don't add any tags from Radar's perspective, but what we do is we store every single remediation action within that DynamoDB, so that's always kind of auditable back to that. And in addition, I had showed a quick snapshot of one of our internal development platforms, kind of that tracks the activity that Radar might have taken against an application's resources. So there's a number of kind of audit trails to what Radar is doing, but other than the remediation action itself, we don't add anything to the resources themselves.
Go ahead.
Do your internal development teams, are they able to see the code and the policies? I know the policies, but the code, how Radar runs, or do you keep that obfuscated from them to, I guess, for security, biosecurity, keep them from finding workarounds?
Yeah, so the question was, do we expose the Radar source code internally? And it is internally available, and we even do allow other application teams to submit pull requests if needed. Obviously, they go through our team and they get vetted accordingly, but that code base is available.
Go ahead.
So, before, it sounds like it's a really big undertaking to develop this tool. Before doing that, did you evaluate any other tools in the environment? And if so, what made you decide to go develop your own tool rather than implement something else?
Yeah, so the question was, did we evaluate other tools before taking on such a large endeavor like Radar? The answer is yes. In fact, Radar was not our first iteration to tackle this problem. It was one of many, And we looked at services like I mentioned with config rules and executing Lambda functions against certain events. Kind of works well into the event-driven approach, but when it gets into the kind of scalability of working with some of those services across the number of accounts and regions that we're working in, it became difficult because you then are deploying that code to every single one of those accounts and every one of those regions. So from an internal kind of operational standpoint, that became very difficult, and we knew that we need to centralize that. And that's kind of where Radar came about.
Go ahead.
What measures do you take to prevent Radar from breaking a production application?
That's a good question. The question is, what do we do to prevent Radar from breaking a production application?
So hopefully Radar made, or there was a validation event that took place in that pipeline before a resource got to production. But if Radar breaks something in production, it probably shouldn't have been there. And more than likely it's missing a security configuration that we deem necessary for that workload to be running there. But again, back to testing. We have a lot of testing, and that's critical. But another piece that I'd mention is around, we have the ability to run these rules in dry run mode. So if we have a new capability that comes online that was not there when we pushed out support for something like S3, and say now encryption became available, that's a real example, we have the ability to run that rule in dry run mode and kind of get a report on what the impact might be before we go live with that.
Do you ever run into exceptions with the development teams where you say, geez, our rule doesn't quite fit this scenario? And do you rewrite the rule to make sure you cover 100%, or do you have like an exception configuration type approach to it? Does that make sense?
So the question is,
Do you have exception flags? Let's say there's a rule, the team says, no, we really got to be able to do that. And
so yeah,
run into it.
yeah, so there's another question around exception policy, and if teams really need to do it, what do we do? And that really lends itself to really the partnership that we've developed with our global cybersecurity team. We, as the team doing the enforcement and running the cloud, don't make those prioritization calls, and we don't make those exception calls either. That's when we partner with either our global cybersecurity team or the security teams within the markets themselves or the business units to make those calls for us, and then we can take action on their behalf. But that's not a call that we would make across the board.
See a couple hands on this side. I'm sorry, what was that?
When was the project started?
When?
When was the project started?
I would say, when was the project started? I would say it's been an evolution of a number of different solutions and products for many years. The tool itself is a couple years old, but kind of the journey that Jay took us through to get there has been ever since the day we started deploying things to the cloud.
Go ahead, way in the back.
The question was, are we integrated with the Security Hub? And no, we're not.
No, not. Go ahead.
Does your team manage all policies across the board, or do different groups within different like, can a different internal division write their own policies if they have things they want to enforce separately or differently?
The question was, do internal teams write their own policies separate from kind of the default configurations? Currently, they're all managed in that single code base. It is extendable, and there are times when kind of certain business units do want to extend that to maybe be further prescriptive on some of those controls, and that capability is there, yes.
Your code probably has nothing to do with your code. Do you handle vulnerability management, or do you have approved AMIs? Are there checks for that type of thing?
The question was, do we deal with vulnerability management, AMI validation, things like that? I guess not explicitly in terms of we have many other processes, and there are other tools that we have that deal with those types of security controls. But Radar itself is more dealt with the configuration of those resources when they're deployed. Yep.
Go ahead and here.
Do AppDev teams get audited or reported against for the amount of remediation they have against the templates?
The question was, do app teams get automated,
Audited?
audited with the number of kind of remediation events against their resources? So getting at kind of calling out who the bad teams might be, if you will. Yeah, so this is something we're always striving towards, getting to that level of, transparency when we open up that data and we allow teams to see that and who's maybe excelling or who's not doing as well as other teams. That's definitely a place that we strive to be, but today that's not necessarily something that we expose. But all of that data is available. We have that available to the internal teams and ourselves, so eventually.
Was there another question over here?
There's one in the back there.
Okay, go ahead in the back.
So, you mentioned that you have exceptions to the past with the rule itself that you can put those in place when you cooperate with local cybersecurity teams that are on site with the bad teams who want some sort of exception in place. I'm just kind of curious in that process that worked out around that. Is your like tracking for those exceptions just like an operating that exception, in place in your definition of the rule, or have you had to develop sort of another process around that?
The question was, how do we manage those exceptions and how are we tracking them? Yeah, so we use Risk Observer to track all of those exceptions that are identified, and that's our enterprise tool. Yep. Go ahead.
Yeah, so the benefits is there are a couple of benefits. One, others could hook into those events if they want. Then they could say it's next iteration of Radar, perhaps another service that does something similar. The question was, why do we use SNS and SQS with the solution? And secondly, it allows us to, it's the only way that you can forward all events from every region into a single kind of stream of events. SNS is multi-region, and you can forward those events cross-region, which is what we do to get them into a single region where Radar is running, rather than needing to run Radar in every region. So.
What happens if that one region you centralized to goes down? Do you not get those events then?
And so the question was, what happens if that region goes down? I don't know. Is there someone from AWS here? Yeah.
Other questions? It's hard to see in the back and
Yeah,
on
it
the
is.
side, so go ahead. Yeah.
Yeah, so you showed demo of like S3 bucket, getting encryption and logging once you basically create a resource. But policy should fail in the first place with your CI checks.
Yep.
So why you need this extra step? Are you still allowing like your developers to manually mess up with AWS resources? So that's why you need like extra layer remediation?
Yeah, so that's a good question. So the reason I walk through both of those is to kind of to force Radar to actually take actions against something in the environment. Of course, everything is going through a pipeline, but that was more to just show Radar in action if something does get into the environment, and then kind of took a step back and looked at what should happen in the validation pipeline itself. So that was the reason for kind of showing the demo that way.
You have like a feature parity between real environment and what your static analyzed. It's basically every single rule you have can be statically analyzed.
Yes, the question was, we have parity between what the pipeline, or how the pipeline is validating those CloudFormation templates and with the rule base that Radar is enforcing. And yeah, that is our intention. If we have a new rule or a new feature is added, if a rule gets added to Radar, there should be a rule added to the validation of those templates itself, yes. Lots of good questions.
Go ahead.
Maybe another one.
Yeah. Sorry, I can't hear you. We have just under 100 rules.
Yeah. I'm sorry, there was a background noise when you asked. Could you? How often do we update rules? So it really depends. Sorry.
I said every sprint.
Yeah, we're always updating rules, but yeah, it really depends on kind of how fast those services are evolving, which as we all know, that's very quickly, so we're constantly trying to keep up with the desired configuration for any new services, yes.
I think you mentioned you were using a rules engine to interpret that YAML file. Can you repeat what that was?
So the question was, are we using the rules engine to interpret the YAML file?
Yeah, the rules that you write.
Yeah.
What was that rules engine?
So we're using an open source tool called Easy Rules.
Easy rules.
Yep.
Thank you.
Another one over here. Go ahead.
How big is your team?
Oh, that's a good question. The question was, how big is the team? There are about 8 people running all of our cloud infrastructure environments, 8 to 10. Go ahead.
Can you sing the Liberty jingle?
No. The question was, can we sing the Liberty
No more
jingle?
questions.
Yeah.
I think there's one here.
That's a good question.
Yeah, the question was, if radar goes down, can you still deploy? So radar doesn't go down. But part of that deployment process is through that pipeline, which is a validation service. So again, that's executing before they're even able to deploy that code, and that is a separate service. So ideally, that validation service would still be capturing any of those misconfigured resources before they could get into the environment.
Go
We
ahead.
got some more over here.
Does anything monitor, like as you redeploy radar, does anything monitor the services that radar provisions?
Does anything monitor the services that radar what?
Provisions, like, does anything monitor the IAM role that radar requires, or any other services that radar spins up?
So asking if, I guess if there's anything that could be revoked or permissions for radar that might mitigate it being able to actually take effect of resources? Yeah. Yeah, so there are kind of separate parts of that, but we do have some global deny policies in effect that ensure that those types of resources cannot be touched outside of the processes that our internal team manages. And that's a different solution from radar.
Over here again. Go ahead.
Basically, radar's got the ability to do enforcement across your AWS estate. So you're also giving quite a huge permission across that. So how are you actually applying least privilege so that radar actually is compromised in some way that doesn't actually cause a systemic effect across your estate?
So the question was, how do we enforce least privilege with radar itself?
Yeah, so you're adding new rules all the time.
Yep.
You've got least privilege unless you're giving radar admin across your entire estate. And you're always going to have to deploy new permissions and stuff. So how are you ensuring you've got the capability to do that without privilege escalation?
Yeah, so we're definitely still following the premise of least privilege with the radar rules themselves. So we're not going to give radar kind of any more capabilities or permissions than it needs to enforce those policies. But yes, it does need a very permissive policy to enforce that configuration. Right.
But is there anything specifically tying the policy that you give it to the rule that it's following?
So is there, I guess, we're asking if there a one-to-one between kind of the policy that radar uses and the rule that it's enforcing?
Yeah, so if, like your example, it destroyed the RDS cluster,
Yep.
right? So it obviously needed delete cluster, or whatever that policy, that permission is in its policy. Is there something that links the policy or the permission in its policy to that specific rule that requires that it destroy the cluster?
So I guess the question was, is there anything that links the radar kind of policy or the IAM permissions to a rule itself? So that is all one single code base, like I mentioned. So whether it's the permissions that radar needs to enforce policy and the rules themselves, anything that's ever done, whether it's a pull request for a new policy that's being pushed, that's going to require an update to both of those things, both the rule and the policy itself. So that is all there, and that's how we would track the permissions needed for a rule for radar itself.
So if you're deploying a new feature to radar, a new capability to resolve this privilege, how do you deploy the required permissions across your 150 accounts without
Yeah.
And remediation means effectively you must have some pipeline that's got full IAM access to all your accounts.
Yeah, so the question was, how do we deploy those policies across all of our accounts? And that's where CloudFormation stack sets comes into play, and that's how we push out updates to those policies across every account. So all of those permissions are governed through AWS organizations. Yep.
So effectively you have got an account that is compromised in any way. So you're actually running in your organization or in a separate account?
I'm sorry, what was the last part?
Are you running Radar in your actual your org account, or are you running in a separate account? I'm just curious on how you're actually ensuring
Yeah.
that you don't have a central weak point, which effectively could have a systemic attack.
Right. Yeah, I'm not sure that I can answer that, but we can chat more afterwards.
Any other questions? Go ahead.
What was one of the biggest challenges you faced with building Radar?
The biggest challenge we face building Radar, I would say,
Implementing deployment, just using it in your company.
yeah, so I would say a couple of the things that I mentioned around some of the key advancements that allowed us to simplify Radar. So prior to Radar, there were some more complex solutions that required quite a bit of overhead for managing the code across all of the accounts, which we were using Lambda at the time, along with config rules. So we knew we wanted to simplify that and enable us to get rules into production faster. So two of the big pieces that we were dealing with is that kind of scalability issue. And so the solutions there were both one with stack sets, and then the other one was the CloudWatch event bus that allowed us to consolidate those events to a single location. Yeah.
All right, we're just about out of time, so I really appreciate those that stayed and asked questions. We'll hang around out in the hallway if people want to ask more after this, but thanks for coming. I really appreciate it.
Thank you.